All right. So on the homework, I do want to point out it does say cut them out and paste them. I do not want you cutting these out and pasting them. If you did them, I guess I wouldn't fuss. What's most important is that when you figure out which one matches in this box, put the letter. Please don't write the function. Okay, put the letter. So if like I think this is A, then I'm gonna write the letter A right there. Okay. Um, and when we'll have a little bit of time to work on that. So if you have questions on that, you'll be able to do that. I don't want you to write the equation in there. You can write A and the equation or A and the thing, but I don't particularly want you just to write the equation because it'd be really hard for me to grade. There's a big part on the state test and an expectation that you can identify whether something's linear, exponential, or quadratic. Go ahead and close Chromebooks. So linear, exponential, or quadratic. Okay, so we've done all three of these. Let's talk about what makes something linear. When we worked on linear, what was like one of the most common things we had to work with? Say again? Right, so we need to know what y equals mx plus b. Absolutely. What is our m? Our slope. So one of the things we had to realize is that what m was, and m is our slope. How did we find our slope?
You have to subtract like two, yeah.
So we might have done y2 minus y1 over x2 over x1. I would say, I don't know why y is on top, but y is on top. Where is y? Just to help you remember that, because that's a common mistake. Or if it was just off the graph, you might just give me rise over run.
I remember this, but I don't think if you asked me to do it before we did this.
This little, right. So we definitely need refreshers, right? And we'll have a big refresher before the state test. So that was the M. What's the other part? What's the B? The y-intercept. And just like we've been doing, anytime you don't know one part, you can plug in an ordered pair and find the other part. Exponential. Let's talk about the different letters here. Do you remember what A was for exponential? Say again?
No idea.
Okay. So we called this the start value. A lot of times if we were writing an equation and I said I started with $2, okay, or that thing that's on TikTok, do you want to take this money or double it and give it to the next one, right? Thank you.
Have you seen that? Wait, can I just see?
Sure.
Have you seen that video where they do that and the girl's like, "Oh, I'll have the dollar," and then the other girl's like, "No." Like
Yeah, I saw it.
she like doesn't give her an option.
It's
She's
like-
like, a dollar or double it to give it to the next one. She's like $1. She's like, "No."
Like,
Like,
you're supposed
you're
to
not-
say double,
yeah,
but
this
then
was a
she's
double
like,
one.
no, I'll have to double things.
You're not supposed to say, I want the money.
Our B, so that's our start is our A. It's also our y-intercept if we saw a graph of it. And then our B, what was our B in this situation? It's not our slope. It is our change. It's our ratio. Or it's I like to just call it my times number. Right? So if I am times that game, double it, give the next person, they're timesing it by 2. So that would be, where do we start with? We start with $1 and then we times it by 2 each time. Again, this is all review, but yeah, it's been a minute, so we're kind of trying to remember it. And then finally, what do you think the most important thing is with the quadratic? Factoring's good, but what do we almost always look for when we're dealing with a quadratic?
GCF.
Okay, I like that thought. No?
No, what's it like? B.
Let me say it this. Yes.
Over,
Yeah.
Negative B over.
Yeah,
What is that?
Negative B over 2A over 2A.
Right?
Wait, that's
He knows that's the one. He knows what it is. He's asking what it's called.
Oh.
It's called
The vertex. Good job. So the vertex is the most important thing. So we know that formula negative b over 2a. I love that. On the homework, there was it asked for the maximum point, and Desmos rounded it for you, and so it would mark it wrong. What's another way to find the max point? Find the vertex, to plug that value in, and then it can give you an exact value. Anyone struggle with that one?
Me, because it rounds. So
It rounds it, right?
then I figured it out, so then I typed it.
Nice. Okay. So then I would say find this next one, because you just plug it in once we know it. Okay. And then also important from this was the y-intercept. And really, to find the y-intercept, that just means what?
Or no, the C.
Okay. What in this one it is a C. Good. If it's mixed up or done in a different way, we just said do what?
0 and for X.
0 and for x. I almost prefer you just to think y-intercept means x equals 0, and then x-intercept.
Do we have our shift on the X?
We did on the thing, but and really it is next chapter.
I never heard questions say on X.
We had some, but next chapter hits heavy. Okay, and then so how do we find the x-intercept?
Y equals 0.
Awesome. Just means when does y equal 0. That's a little bit trickier, and we're going to learn that next chapter.
When's our unit test for this?
Soon. This is our last section. So I think it'll be
Like week?
Wednesday. Did I ask you guys to close your Chromebooks?
Yeah.
Oh, did I ask Luke to change? Luke?
I think you did ask him and he didn't, so I think that's the point.
Okay. I think he did, and then he undid it.
But then like every 5 minutes.
Is he on it now, Hannah?
Yes. No, like how are you listening, telling him to tell you to stop and you're just like sitting there?
Yeah.
Sorry. I'm
Like
just
every
stop.
5 minutes.
All right, I'm going to open the window. Someone grab his ankles.
I got you.
Bro, close it. He told you to.
Should we take the screen off before we throw him out? Or
No.
Yeah?
No.
I mean, it's kind of fun to have the screen kind of hit you as you're going out. Luke, I am inviting you to close your Chromebook. Thank you. Okay, next problem. So these are kind of interesting. We want to be able to figure out whether it's linear, quadratic, or exponential. If you're given a table, okay, they can be very tricky and maybe give you points that are like this, right? So I could graph them, and they could give you 3 points like that. It might, to me, that looks linear. They could be tricking us by having more points over here that we don't see. And once I realize that, but they don't give us those points, if I knew those, I'd say it's quadratic, right? Or they could be hiding the points down here, which makes it exponential. So giving us just 3 points, I don't know if it's linear. I don't know if it's a parabola or a quadratic. I don't know if it's exponential, right? So if they just give us those 3 points, okay? So there's a test, and it's called the first difference, second difference test, and I think it's actually kind of interesting. When I look at this, I want to be able to figure out the first difference. My first difference, and they're very nice, and they put these all 0 through 4, and they're all 1 apart. What is that difference right there? 2. And the next one? 2. And the next one? And the next one? And I think I feel like I gave you, okay, and then 2. Second difference means how much did these change by? 0. If the second difference equals 0, then it's linear. And really, you could kind of see that from the first because it's being added by 2 each time, and that's what linear kind of means. Where we have to be careful is the ratio one might throw us off, but let's just go with this. This next one, I want to figure out the difference. Can you tell me what this difference is? 0.75. And then this one, 1.25. And then this one, 1.75. And then this one. Good. Who's our calculator? Who was that?
No.
How is it 2.25? It's
I think 1.75.
It's 1.75.
1.75.
Did I skip something?
Yeah.
yeah.
That's
Because
two.
you can't go
Yeah,
from
like 2.25 to 4.
1 to 2.25.
It's 1.75.
So tell me Hannah, tell me the first number you have on your sheet. This change right here.
1.75.
Okay.
Wait, no, that's 0.75.
Right. And then 1.25. And then 1.75.
And
And
then 1.75.
2.25. Huh? We okay?
Where is that?
1.75.
Where 1.7?
Oh, I was looking at the difference between the 2 and the 4.
So did you write them a down one?
Yeah.
Okay.
No, I just.
Someone want to translate for me? Are we still confused?
No.
We're okay?
It just looks.
Yeah.
I think the mistake was they were subtracting the bottom to the top and not adding the top.
Okay.
I just don't know the first one's 0.75.
First one's 0.75 because I went from here to here. So to get from there to,
Most people made it so all of them would just scoot down.
yeah, so your column is down one. I have a blank at the bottom, you have a blank at the top.
No, I just.
Difference here.
Wait, what?
0.50. Difference here. 0.50. Difference here. If the second difference are all equal, then it's a quadratic.
Oh yeah, I remember doing these. But 0 is equal to 0. We've done something like this before.
No. Remember, C can be a quadratic, so it's like,
Yeah, 0, 0 equal to 0, so it would be quadratic.
So if everything is equal.
oh, okay. Let me say it. And I like that. Okay, so you're talking about over here. Second difference, all equal, but not equal to 0. Good catch. Thank you for that.
So everything but 0.
Mm-hmm. Okay. So next one. So common difference here. I'm going to grab my calculator. So really I can just take 0.25 and subtract it from the one before. I think it makes more sense to everybody if I put this number right here. Is that right? And then there, 0.5, I can do that in my head, right? 0.25. And then here's 0.5. And here is 1. I hear somebody whispering at the answer, they think. Okay, so then this difference right here, 0.125 minus 0.25. Oh, already did that, right? So it's the same thing, right? 0.125, 0.25.5. I subtracted these two.
Yeah, just 0.1.
Oh, goodness. The rest okay?
Hooray. Yeah.
So this is not doing anything. Okay, so really I want to figure out, I'm going to go the other way here, and I want to figure out what is my other thing that's happening. So we could have where the it's changing by the same number, and then therefore the second one's 0, right? It could be that it's changing. The second one's changing by this. What would the other case be? Exponential, which means it's being what? By how? By multiplication. So the question is this being multiplied by the same number each time? I don't know about you, but I kind of look here and I go, that number here has been changed by, I don't know, I feel like I want to write it here. Is that okay? That's being times by 2. How about here? Times by 2. How about here?
Times by 1. 2. Just
And then this one here, and I could confirm that, right? I could go, what is 0.25 divided by 0.125? And I get that it's being times by 2. So that means it's a what? Exponential. So if we have a common ratio, okay, then it's a exponential. In some ways, I totally would not be surprised or fuss if you just wrote that on there and did none of this work. Okay. If you do this work here, though, you kind of see that nothing is happening. It's kind of a big hint that it's the other thing. Yeah.
What if it's none of those?
I wouldn't give you one like that. We're not there yet. Okay.
Will we learn that in this class?
Say again?
Will we learn that in this class?
No. And really, even in Algebra 2 or beyond, it's like if you're a scientist and you're doing this stuff and you're trying to figure out the rate of change or like what's happening to something, then maybe you'll get weird data, but then you kind of push it to fit to something. Okay. So this next one, how would you want to approach this? If you now know that we need to either show that it's being added by a number, or that the second difference is the same, or is it being multiplied by something? I kind of want to look at it and go, do I think that anything's being multiplied here? No. So then as soon as that's out of the door, okay, if I say explain, like it says in the directions, where is my explanation?
On the ground.
On this table in terms of, is it a first difference or a second difference thing? So I go to my calculator and I go 100 minus 89.5, and I get that this change right here, I almost want to just write it in the middle, is 10.5. I'm sorry? And then I want to do this one, 78.9 minus 89.5. Thank you. Okay. And then I get negative 10.6. And then I want to figure out this change, 78.9 minus 68.4. And I get negative 9.6. Did I make a mistake?
Did you not put the point in the calculator? Oh my gosh, I have to.
You're right, I didn't. Thank you. 78.9 minus 68.4. Thank you. 10.5. Good catch, Hannah.
Good job.
And then I'll do the next one. 68.4 minus 57.8. And I get 10.6. It is a pattern, isn't it?
Isn't it a positive?
So in reality, no, it went smaller, didn't it?
Wait.
They're all going down.
Oh, wait, never mind.
In reality, we already should kind of know what this is based on the 3 categories we're going to choose from. Is it linear? No. Okay. Is it exponential?
No.
No. Is it quadratic?
No. Yes.
Okay. It's got to be one of the 3. when it says explain, if I stopped here and I just said quadratic, if it's on the computer, boom, you're fine. Okay. But if I'm asking you to explain or show work, then we have to show this change.
What if you're a
Negative
computer?
0.5. This goes down. So this goes down by negative 0.1. This one goes up 0.1. And this one goes. Now, the difference we're not going to consider, actually, we don't have to consider whether it's a positive or a negative change. Okay. So if the second difference is all 0.1, that means we've proven that it's quadratic.
That works for anything, even if it's like, even for the second difference, if they're negatives, that works. If it goes negatives and positives, that works.
Yeah.
So if it's like negative 100, positive 100.
In theory, I didn't actually have to consider these being negative, right? Even though it went down. I could have just put 10.5, 10.6, 10.5. How far away are they? Okay. So that's yeah.
I'm confused how it's quadratic if it's still equal, if they're all still like 0.1.
Like why is it doing that? Is that what you're saying?
Yeah, because like the other ones are oh, never mind. I just looked at the top one.
Yeah. So we said over here, second difference are all equal, but not equal to 0.
Yeah, I thought.
Okay.
I thought mixed up with that.
Okay. You good?
Yeah.
Okay. All right. So next, I gave you ones like this because sometimes people get confused when it's not written the same way. Okay. So all I got to do is I got to just put the second or first and second difference on.
I'm sorry, I didn't write it down, but if all the second is 0, what is it?
If all the second is 0, then it's linear.
Wait, so you said you don't have to just write like whatever the answer is?
I said the opposite. If it says explain and you don't have any of this work and you just have the answer, then that's you did not explain. Okay? So like this one right here says explain, then that means I need to make a table, right? I need to put some values on here. I kind of don't like the table. I almost wish the table was like this, right? That kind of makes more sense. What's the common difference? And again, these are in order, so that's good. Common difference from -2 to -5 is 3. And then it goes, is that 9? Thank you. 15. 21. And then we got to figure out what our second one is. 6, 6, 6. So in mathematics, you don't have to explain words, but drawing that on there is our explanation. I don't know about you, but when I look at the next one, I kind of get a gut feeling. I already know what it is.
Same.
What do you think?
Exponential.
Exponential, and what do you see?
I think we should just erase 6 plus
Yeah. So what do you see there?
time.
By what?
6
Times by 3.
Times by 3. So here's my explanation. I show that that's being times by 3.
What?
I see that this is, I can do that in my head. I don't know about you, but I don't know what 36 times 3 is. But I get 108.
108.
So that tells me that that's that. And then if I times that by 3, I get. So there's my explanation. That's all I have to do to explain it. So to be clear, on the homework, if it says show work, right, then I expect to just see these little tables. Okay, it's really not a lot of work. You just got to show it. Though the homework doesn't have anything like that, but yeah. We have to be able to tell whether it's linear, exponential, quadratic, 3 different ways. The equation, table, and then finally just looking at a graph. The graph one I think is the easiest one. How do we know if it's linear? It's just straight. Okay. I don't know about you, but I feel like I should grab a ruler, but I don't have one. You don't have one, but we just want to draw the straightest line we can. That's how we know it's linear. Exponential. Remember what that looks like.
It's like weed.
It's like It's like a slide.
Yeah, slide.
No, a roller coaster.
And it could go the other way, right? Do you remember what the name of the graph of a quadratic is? What the shape's name is? Parabola.
Whoa.
In a quadratic. So there could be a question on the state test, and it shows you like this picture, and it says, is it linear, exponential, quadratic? I really hope we all get that one right. Okay. Compare the following functions. Show that x increases, or show that as x increases, h of x will eventually exceed f and g. Show with a graph. Okay.
We don't have a graph.
So when we could have a race, right? So basically what this question's asking is if I have a line that's going very, very straight up, okay, I could have a parabola that's also very, very, very steep. And then I could have an exponential that's not very steep. Something like that. Which one's going to win over time? Green, black, or pink? So green is winning right now.
No, the steep one's gonna win it.
But no, it's the
pink one.
it's the pink one.
The pink exponential always wins. It might be slow to start, but in the long run, as the further you go, it's always going to win. What do you notice? What do you notice h of x is? H of x is the pink one. Okay, so they're saying even though these ones are fast, pink will eventually win. Show that as x increases, that pink will eventually exceed or be above f and g. So when you think of graphing, that makes you think you want to look at what? Desmos. So if I jump on Desmos real quick, I have to visually show what they're getting at. Where is there it is. Okay. And I want to show that my first one, y equals 3x plus 2. And then my second one is y equals 2x squared. I wonder if it lets me, does it let you put in
Yeah, it does.
f of x?
Oh no, I don't know if it lets you put an fx, but I put in like t for instead of x. Like in the
What if I put f here? Will it let me do that? Okay, cool. We've got G, and then finally H is our star that we say will beat all of them over time, and we have to show that. So this is kind of illustrating what I drew. My colors are different now. Hopefully that doesn't confuse us. It does. Let me change them then. How do I change? Right click.
You gotta
No.
setting.
Hold it.
Yeah. That did not work. Go to settings up there in the top right.
Oh, no, it worked when I held it.
Well, you can't
Just-
do settings.
Oh my God. Does
Come on
not
now.
confuse me.
Yes,
Come on
it
now.
does.
Only brain is
I said that was pink, and we have black and green.
You can never be slow in a good way.
you can't. That turtle, he was slow.
Okay, so again, the pink here looks like it's not going to win, right? So if we're talking, if this is money, right, and we're talking about only one day, say we put one here, we want to take either black or green, okay?
Black.
But over time, that pink, okay, is going to beat black very quickly. And then it's going to eventually beat green. Okay. We want to kind of figure out where does that happen. So I'm going to write down these ordered pairs. Is that what I want to do? No, I just want to model this. Okay, so we go back. I kind of modeled it here, but I want to show H winning. So I'm going to draw H. And at the end of the graph, I'm going to go ahead and write H of X. I have the fortunate to have different colors here. And then for F of X, I want to show that it was winning, but then that it eventually lost. There's my F of X.
That looks curved.
It's totally curved. It shouldn't be.
It's not supposed to be curved.
It's not supposed to be.
But I did.
And then finally, my parabola. It was the one that held out the longest, but it did something like this.
Blah, blah, blah.
That's an awful graph. And that one is G of X. I should have maybe drawn my other ones first, but I think we get the point. Okay. Okay. All right. Looking at the next one. So now they're gonna say same question, but I only want you to look between 0 and 0.5. Are they the exact same functions?
No. I mean, yes, they are.
So that means we go back here. I'm going to go back to home, and I only care about from 0 to, for X from 0 to 0.5. I could go up to my wrench here, and I could change this and say on my X, I'm going to go from 0 to 0.5. Here's something I want to point out, that you kind of want to go beyond it if you want to look at 0.5. Oh,
54.
okay, I want to look at 0.5. Actually, that's not terrible, but sometimes it's nice to go beyond it. Who's winning here?
No one.
Green.
It
Black.
is-
Black.
It would be black, yeah.
Wow.
Oddly enough, what do you notice? It's giving me that dot there.
That means that that's when they touch.
That's when they touch. And where is it? Can you see it? It's at 0.5. So who wins, black or green?
Both of them.
As of right now,
They're tied. They're tied.
That's why I
Okay.
said
to go over.
Okay, so let's go over this again. So we need to draw this picture. And that's kind of tedious, and they don't ask you to do that a bunch. I'm only asking it because I think it helps us understand. Okay, so they're asking us to draw this picture. So my H of X, honestly, it's not really gaining much speed. It actually almost looks straight to me.
which one?
My H of X.
That's not look straight.
Okay.
To me.
We just need to make sure it's losing. And then our green one, which is our parabola, that's the only one that I can actually see some curve in.
What is that? Oh, I thought you were meaning like straight, like this straight, not like curved.
Yeah. And that's our G of X. And then finally, our linear one, which is our black one, is just going to win right here. Yeah. That was not very straight at all.
Okay.
Thank you. Here's what we got. Here's the point of this. And I think when I wrote this question, I think these are out of the book, but when we look at these, I want you to be able to tell me which one's winning. Your gut instinct says, oh, exponential always wins. Is that true?
No.
No, it depends on where we're looking at. If we're racing to 1 million, exponential is probably going to win. Okay. If we're looking closer to 0, we don't know what's going to happen. Okay. And then finally, the same exact thing, but they want to see what's going on between 3 and 5. Again, I can go to my wrench. I can change that. I only want to look at X from 3 to 5. Something I want to point out is what just happened here. What is it?
Nothing.
Why?
They're already there.
They're up higher. So what I like to do is when I see that, you can go up, but let's go back to our wrench. I want my X to be between 3 and 5, but my Y needs to be bigger.
Your Y should be like 10 or 2 to 10.
So right now it's -2 to 10.
Negative 2 to 10. Oh, then it needs to be like 20.
Let's go up to 20. So yeah, you can play with this. Now I see 2 of them. I'm missing one. So what should I do?
Make it like 5.
Make it so here's something I like to do. I don't like to get rid of my negative because I kind of want to have a sense of where my X axis is. But I'm just going to keep adding to this. I went to 30.
And now we see what
Now I see them, but I want to see what's happening, who wins, right? So I got to keep going.
go to like 45.
45, 50.
You might as well just go to 100.
50.
So I don't want to just go so big. Now I went to 100 and that actually kind of worked. Okay. But I wouldn't want to go to like 2000. Right. Because and they just kind of disappeared on me. So you want to make sure that you're kind of being careful with that. Again, my window, right? When I look at this, when I hit the home button, it goes from -10 to +10 both ways, right? I want to look at X being between 3 and 5. So I moved my window and then I looked and then I stretched it. Okay. And there I got a good picture. How high should I have gone or could I have gone and gotten even a nicer picture?
Like negative
10.
I don't, it's not that. How high did I need to go? I didn't have to go all the way up to 100.
You could go to like 60.
I could have gone to 60. So I could come down here and I can make even a nicer picture, right? Because I'm going to give this to my mom. And I can do that. Okay. So which one wins in this case? Say again. G, which is our quadratic. Okay. So then I have to draw this picture. I'm going to draw my quadratic first. I want to draw my exponential. We see the exponential past the linear. That's my h of x. And then finally my linear was winning, but then lost. Question I could ask, who's winning at 3? G, who's got second place at 3? H. No. F. We're talking about this end, right? Because this goes from 3 to 5. So be careful, right? When is H and F tied?
At 4.
Okay, looks like 4. I don't know. I'm going to click here. If I ask that question, I would want to answer 3.717, right? So I could ask all kinds of questions based on this little window. Okay. So going back to this, Miss Walters made this or got this, and I kind of liked it. Like all I need to do is I need to find. I know. Don't let her know that I said that, but yeah.
Did she know you stole it?
I literally walked in her room after
You just snatched it.
school one day. I put on a black mask and all black clothes, and I had a.
Oh,
All right, so for this one equation, I need to figure out which of these is the graph, which is the table, and what type of function it is. Obviously, the type of function is not a letter here. So the type of function, this is linear. So you just write the word linear. Then you have to find the graph that this is. and then you got to be able to put the table on there.
I can just like plug that into Decimus, right?
So for
You could, but I don't think you need to, do you?
Yeah, no.
Wait, you have
Yeah.
to explain.
There's no explanation on this. You just have to write the letter here. Yeah.
so for the type of function, just write linear, quadratic, or exponential.
Yes. So you're going to write one of those words there and then put letters here. Absolutely. I think it's going to make you crazy if you don't rip this back page off.
I did it.
There should be none of these should be used twice. So once you use it, if you're right, then you're good. Okay. We got about 8 minutes, maybe 5 minutes. If you want to go ahead and start looking at this, figuring it out. This is the last